Welcome again, MEEN210 class. In this video, I will be solving the parts exercises that I provided you during the last lab session. We will start with this part, the pinion mount. So, as you see here, the part in itself is very simple. If we can divide it into sections or features, let's say, we can divide it into 1, 2, 3, and 4 different features. There's this base disc, and then there's this intermediate cylinder, and this top cylinder, and then there's an extruded cut from the right hand side. As we discussed during the lab, there are multiple approaches that you can follow to build this part. One of them would be by sketching circles and extruding them one by one until you achieve the full geometry, and then on this face, on the right hand side face, you can draw this profile and then extrude cut towards the inside. Although this approach will require that you make the part using 4 different features. There is another faster approach, and this would be by using a revolved sketch, like what we discussed during the lab session. So if you draw half the profile or half the cross section of this part and you revolve it around the longitudinal axis, you will get the exact same result just in one feature, and the last thing you need to do would be the extruded cut. So let's get started on doing this. So we will be doing this shape. I'll go and start a new part. You need to make sure that the unit system is the one that's required, and in our case it's mmgs or millimeters. And I will pick the front plane. I will start a new sketch. And I will start by drawing my axis of revolution, which will be defined by a center line. Next, I will use the line tool to draw the profile approximately. Then, as usual, we will refine it using the dimensions and relations if needed. So here is a close profile, and on the next page you will see all the dimensions, and I will simply replicate those. This is 30, this is 10, here 13. And as I always emphasize, please try to put the dimensions on your sketch in the same arrangement and also in the same place if possible as the ones provided in the drawings, because this will make it a lot easier for you to review and spot if you have any mistakes or any missing dimensions. Okay, so here I think our dimensions are fine. Our sketch is fully defined. We can exit, select revolve from the features. It will show us the preview. If you accept this result, you can click OK, and here is the part. The next step would be picking this face and starting a new sketch, and we will need to draw this incomplete circle. So we'll draw a circle, and then we'll draw a horizontal line touching the circle perimeter on both sides. Then we will trim away the unneeded part of the circle. So with the circle command active, I will just touch excuse me, I will touch the circular edge of the face, and this would highlight the center point. Then you can go and click that center point to snap the center point of your new circle to it, and then go to the line tool. I will start from one side towards the other side, and I was careful enough to follow the horizontal guideline. So here my line came out horizontal. If the horizontal relation was not automatically added, you can simply select your line and make it horizontal. Then I will go to the trim entities tool, and I will need to delete the extra part or the top part of the circle. And I would do this with the power trim selected. I will click outside in the background and then cross the arc that is not needed. And this would give us the shape that is required. The final step would be adding the dimensions to this sketch. So we have the radius here of the arc equals 15, and the distance between the horizontal line and the center point is 12. So with the Smart Dimension tool, I will add a radius of 15, and I will add the distance from the line to the center point as 12. Sketch is fully defined. We can exit. Now we need to remove material with this sketch, so I will extrude cut with a depth of 25 millimeters. And this would be our final completed shape. For a self-check, apply a brass material. So go to the materials line, right click and select brass from the favorites. Don't worry if your part looks a bit different than mine. It's fine. These are some graphical differences. So after applying the material, we go to the Evaluate tab, select Mass Properties, and make sure that your mass is 572.28 grams. If you got the same mass, then you have followed the steps correctly. And this concludes the steps to create this part. I hope it was clear enough. Moving on to the next exercise, which is the pressure disc. So this is the required part to build. It's a fairly simple shape, but it's slightly different. Our previous part was a solid part with a straight extruded cut, but this part over here, you'll see in the next pages that it's a hollow part, like a cover. But what is common between this part and the previous one is that both of them are round and both of them are symmetric about one of the axes, which means that it makes sense to create such parts using the revolve tool. So imagine if we have a center line or an axis passing vertically through this part, we can easily draw one half of a cross section and revolve it around that center line. But first of all, let's think about what dimensions or information we need to be able to create this part correctly. So we will need to know the diameter of that inner hole, and then the diameter of the second hole, and the diameter of this cylindrical face, and the outer diameter. We also will need the height, we need the thickness of this part, the thickness of the flange part, and the information about these small holes. So if we scroll down in the document, we will see that they provided us with a few images that have some information. Here we have 1, 2, 3, 4 diameters, which are the 4 diameters that we need. And we also have the information about the small holes that are listed as 16 times a 12 millimeter diameter. So this means that we have 16 copies of those small holes equally spaced around the part, and each has a diameter of 12 millimeters. And the center distance between the small hole and the center hole is 182 millimeters. On the next page, we have 2 side views. One of them is a complete side view, and the other is a section view. So the complete side view has the total thickness of the part, has the thickness of the top cylinder, the radius of the outer curve, and the thickness of the flange. And the lower drawing here, this is a cross section of the part, and it shows us exactly what we will need to sketch. So what we need to sketch is only this one of those shaded sections. And it also is showing us that the part is hollow, and the thickness, the wall thickness of the body shell is 10 millimeters. So since all of these are 10 millimeters, so this means that the line that defines the inner surface is parallel to the lines, or are parallel to the lines that define the outer surfaces. Okay, so with this information, let's get started with building this part. So what I'm going to do, I will use this sketch over here, which represents the half of the cross section, and I will draw that in my sketch. I will start a new part, make sure that we are on millimeters, system of units. I'll select the front plane and I'll start a new sketch. I will begin by drawing my vertical axis of revolution as a center line or a reference line. Then I will start drawing the bottom set of lines that define this profile. So I will start by a horizontal line, a vertical line, another horizontal line, a tangent arc, a vertical line, and a horizontal line, and I will exit the command. The next step is that I need to create another copy of this same exact sketch, but 10 millimeters above or below it. Okay, so to do this, you can do it in the same way manually, but in that case, you will need to add the 10 millimeter dimension between each two similar sketch entities, and this is just a time waster. But the other faster solution is to use the offset entities. If you remember, offset creates a copy of your sketch or multiple sketch lines that is parallel to your original sketch at a specific distance and direction that you define. So what I need here is that I need a copy of all of these sketch lines that is placed 10 millimeters above my original sketch. So with the offset entities command active, I will define the distance already predefined as 10 millimeters. I'll make sure to select chain is selected. Select chain means that as you click one element of these sketch lines, it will select all the connected sketches at once. And here, as you see, you can see the yellow preview, but in this case I need this to be offset towards the outer side, so I will reverse the direction and then I will accept. Now we have a offset copy of our sketch towards the outside. Finally, with the line tool, I will close the ends of this sketch. And now my sketch is complete. It needs to be refined using dimensions. Okay, so using the dimension tool, I will start by adding the dimensions that I see here in this side view image. So we see here that the thickness of the total part is 75 millimeters. So I'll pick the top and bottom lines and I will add a 75 millimeter dimension. Then the thickness of the top part, which is this one, is 15. So I will make this 15. The radius of the outer curve is 30. So make sure to pick the outer curve. Be careful when selecting lines or curves. Do not select the points. Select the lines or curves themselves. So this has a radius of 30. Let me undo this for a second. I need to pull this out a little bit because as I change this to 30, the line disappears. And now I've added all those dimensions. The remaining dimensions would be the diameters. I will start by adding the outermost diameter, which is the 400 millimeters that defines the diameter of the outer edges. So I will go to the Smart Dimension tool. This line defines the outer edge of the part. Again, make sure you select the line, not the point. And I will add the dimension between that line and the center line. If I want this to show up as a diameter, you simply cross the center line towards the other side and you will see that the dimension shows as a diameter, and add its value as 400 millimeters. Next, the second bigger diameter, which is the 330 millimeters, and you will see that it starts from this side towards that side, which is this line. I will go towards the center line, cross to show it as a diameter, and then add 330. The next diameter is the 170 millimeters, which is the small cylinder on the top. This will be 170. And finally the inner hole from here to here, and this is 100. As you see, the sketch is now fully defined. It has all the dimensions and all the required relations. Now I will exit. I will go to Features, Revolve, and you will see the preview, which is correct, and I will accept. The next step is adding those small holes. So I'll pick this face. I will create a new sketch on them, on that face. Let me just get rid of the shadows. Okay, and for this, what I will need to do is I will draw this large construction circle, and I will draw one of those small circles. So here's the construction circle. I'll make sure it's for construction, and next I will add one of those small circles. Then I will add the diameter of the small circle, which is 12 millimeters, and then I will add the diameter of the big circle, which is given here in the drawing as a radius of 182. So I will add the diameter, which equals to 182 times 2. You can actually type it as an equation and press enter. It will do the calculation for you. Or you can right click on that diameter and go to display options and display it as a radius if this makes you feel more comfortable. Now you get a fully defined sketch, and you can exit. We are removing material, remember, so we go to extruded cut with a through all end condition, and this creates the hole. The next step is the circular pattern. So we go and find the linear pattern button, click the arrow below it, select circular pattern. Then we need to select, first we need to select the direction of rotation that we need to pattern around, which here in this case will be the axis of the part. So to select the axis of the part, you can simply select any cylindrical face on that part, because all of them share the same axis. So I'll select this face, for example. I need 16 copies. Make sure to type 16 and select equal spacing, because we need this all the 16 equally arranged around the circle. Finally, click inside the features and faces box and select the small hole. If you cannot select the hole from the graphics area, you can simply open the design tree from here and select the feature that created that hole, which is the extrude cut. Then accept, and you will get your completed part. Finally, as a self check, apply a material. Let's add, for example, cast alloy steel material. Here's a nice textured material. Again, don't worry if your part looks slightly different than what you see on my screen. Then we go to evaluate, mass properties, and the mass is 11,878.14 grams, 11878.14 grams. I hope this video was useful and helpful, and please watch it completely and try to build the parts on your own, and hoping you can get all the features and commands without any issues, inshallah.